21. Solve the polynomial equation by factoring and then using the zero product principle. 7x to the fourth equals 448x. Use a comma to separate answers as needed. Simplify your answer. Type your answer in the form a plus bi. So this problem is pretty long, but if we take it step by step, it'll be okay. The first thing we need to know is step 1. In this problem, we'll be getting 4 solutions, and we'll get them using the zero product principle twice. So we'll use the zero product principle to get 2 of our solutions, and each time we use the zero product principle, we'll get 1 solution. Then you'll use the quadratic formula, which will give you 2 more solutions to put in your final solution set. So step 1, we want to go ahead and get 0 on one side of the equation. We need to subtract 448x from both sides to get 0 by itself. And once we do that, we'll end up with 7x to the fourth minus 448x equals 0. So let's rewrite our equation. 7x to the fourth equals 448x. So we want to get 0 on one side, so to do that, we'll subtract 448x from the right side and also from the left side, minus 448x, and that gives us 7x to the fourth minus 448x equals 0. Now step 3 is to go ahead and factor 7x to the fourth minus 448x, which becomes 7x times x to the third minus 64 equals 0. So we can just go ahead and factor this out. And to factor this out, we just have to say, okay, what part of each term is common to both terms? In this case, both terms have the variable x, so that's common. And then also both terms are divisible by 7. 7 is divisible by itself, and 7 goes into 448. So that means the factorization would be 7x, and then in parentheses, what times 7x equals 7x to the fourth. It would just be times x to the third, and then minus, how many times does 7 go into 448x? Well, or into negative 448. Well, 7 goes into 40 times, 7 goes into 44 6 times, because 7 times 6 is 42. So 6, and then we're left with 2, and then 8. 2 goes into, or 7 goes into 28 4 times. So 7x times negative 64 is negative 448 x. So that's our factorization right there. 7x times x to the third minus 64 equals 0, and that's what we have right here. Now for step 4, we want to go ahead and set both terms equal to 0 using the zero product principle. So set 7x equals 0 and x to the third minus 64 equals 0. So 7x equals 0, and then x to the third minus 64 equals 0. And then we need to solve for x for 7x equals 0. We can do this by dividing 7 by both sides. So if we divide 7 on both sides of 7x equals 0, then we end up with x equals 0. And x equals 0, this is solution number 1 for your final solution set. So x equals 0 is solution number 1 for final solution set. Okay, so now we did that, and moving on to step 5. Moving on to step 5, it says, notice that x to the third minus 64 is a difference of 2 cubes, since it is in the form a cubed minus b cubed. So right here we have x to the third minus 64, and x to the third minus 64 is a difference of 2 cubes because you have x to the third and then 64. Well, 64 is just 4 cubed, so minus 4 cubed equals 0, or just minus 4 cubed. And then because this right here is a difference of 2 cubes, to continue factoring this, right here, to continue factoring, we want to use the formula to factor a difference of 2 cubes, which is this one right here. A to the third minus b to the third, which is the form we have it in here, equals a minus b in parentheses times a squared plus ab plus b squared. So we want to use this formula right here. And in this case, a is equal to x. Our a value right here is going to be x right here. And then 4 is your b value for this formula. So this b, 4 is going to be our b value. And then we just have to go ahead and input the a and b values into the formula. And once we do that, we should end up with x to the third minus 4 to the third equals x minus 4 in parentheses times x squared plus x times 4 plus 4 squared. So if we plug these in, we have x to the third, which is our a to the cubed, minus b cubed, which is 4 to the third, equals, well, we have a minus b. For us, a is x, so we have x minus 4, because 4 is our b value, and then we need to input a squared. A squared is just going to be our a value, which is x squared, and then plus, it's going to be a times b, so plus x in parentheses times b, which is 4, and then it should be plus b squared, and our b value is 4, so just 4 squared, and all of that in parentheses. So now that we got our difference of 2 cubes into the formula for factoring a difference of 2 cubes, we can go ahead and move to step 6. And step 6 says start with setting the factorization of x minus 4 equal to 0 using the zero product principle. To solve x minus 4 equals 0, it wants us to add 4 to both sides, and then x will equal 4. So the first thing it said is to set x equal to 0. We want to factor this left factorization, x minus 4. So x minus 4 equals 0. And then to get x by itself, add 4 on both sides. So we end up with x equals 4. And then x equals 4 is solution number 2 for your final solution set. So x equals 4 is solution number 2 for final solution set. And next we can go down to step 7. Step 7 wants us to evaluate x squared plus x times 4 plus 4 squared, which becomes x squared plus 4x plus 16. So this left part right here we need to evaluate. We need to evaluate x squared plus x times 4 plus 4 squared. So x squared is just x squared. X times 4 is just 4 plus 4x. 4 squared is 16, so plus 16. And now we have a trinomial. So next we want to go ahead and step 8, we want to set x squared plus 4x plus 16 equal to 0. Now this equation is in standard form, ax squared plus bx plus c equals 0. So we have this final factor right here, and we're just trying to get it into standard form. And to do that, we just set this factorization equal to 0. So x squared plus 4x plus 16 equals 0. And that gives us the trinomial in the standard form of a quadratic equation, which is ax squared plus bx plus c equals 0. Now for step 9, to continue factoring this trinomial, we want to go ahead and plug in step 9. We want to plug in the a value of 1, the b value of 4, and the c value of 16 into the quadratic formula. And we know our quadratic formula is minus b plus or minus b squared minus 4ac all over 2a. So we just need to go ahead and plug these values right here into the equation. And x is going to be our a value, x will be the a value, 4 will be our b value, and 16 will be our c value. So we'll just plug that into this formula. So we have minus our b value, which is 4, and then plus or minus our b value is 4, so b squared, and then minus 4 times 1, our 1 value is just x, which is the same as 1x, so it's negative 4 times 1, and then that's times our c value, and c is 16, so times 16, and that's all of that is over 2 times a, and our a is 1, so 2 times 1. So now moving to step 10, we can go ahead and evaluate the quadratic formula. So if we evaluate this, we have minus 4 plus or minus 4 squared is just 16, negative 4 times 1 is just negative 4, and then times 16, and then we have 2 times 1, which is just 2. Okay, and so you have negative 4 plus or minus 16 minus negative 4 times 16 is just negative 48, and all of that's over 2. And then keep simplifying. Negative 4 plus or minus 16 minus 48 is actually negative 4 times 16 isn't 48. Negative 4 16 times negative 4 is actually 64, so it should be 16 minus 64, and 16 minus 64 is negative 48, and all of that is over 2. And And then for step number 11, step number 11 is the square root of negative 48 factors to the square root of negative 3 times 16 to square root of negative 3 times 4 times 4 to 4 square root negative 3. So we can factor the number under the radical, and negative 48 will factor to negative 3 times 16 over 2, and then that will factor to negative 4. I'll factor to negative 4 plus or minus negative 3 times 4 times 4 over 2, which will factor to negative 4 plus or minus 4 times square root of negative 3 all over 2. And that's what we have here. And now for step 12. Step 12, you don't want a negative number as the radicand. In this case, you have 4 square root of negative 3 divided by 2. Remember, 4 square root of negative 3 is the same as 4 square root of 3 times negative 1. So, right here, square root of negative 4 plus or minus 4 square root of negative 3 is the same thing as just negative 1 square root of negative 1 times 3 all over 2. And then we can go ahead and substitute I squared for all negative 1 values. So if we do that, we have negative 4 plus or minus 4 square root of I squared times 3 over 2. And then if we keep simplifying that, negative 4 plus or minus 4 square root, our I squared just becomes I, and then square root of 3 all over 2. And it says that here, 4 times square root of 3 times negative 1 divided by negative 2 becomes 4 square root of 3 I squared over 2, and when factored becomes 4I square root of 3 divided by 2, and our equation is now negative 4 plus or minus 4I square root of 3 over 2. And yeah, you have to make sure you include the plus or minus. Just keep carrying that over. So now moving to step 13, we can go ahead and simplify 4 plus 4I square root of 3 divided by 2, which becomes 2 plus or minus 2I square root of 3. And we can actually rewrite the equation. So negative 4 plus or minus 4I square root of 3 over 2, and then 2 goes into itself once, 2 goes into 4 twice, 2 goes into negative 4 twice. So we have negative 2 plus or minus 2 square root of 3. We don't need the 1. That's redundant. Which is the same as, well, actually, that's addressed in step 14. Step 14 says include the negative and positive solutions, which are 2 plus 2I square root of 3 and 2 minus 2I square root of 3. These solutions are solutions number 3 and 4 of your final solution set. So this right here is the same as writing each individual solution, the positive and the negative solution. So you have negative 2 plus 2 square root of 3, which is the positive solution, or negative 2 minus 2 square root of 3, which is the negative solution. And these two answers are solutions number 3 and 4 of your final solution set. And then for step 15, for the last step, you just want to combine all 4 of the solutions into one solution set in set builder notation, which should be 0 for 2 plus 2i square root of 3, 2 minus 2i square root of 3, all inside curly brackets. So we're using set builder notation, and we want to use all 4 solutions. If we remember, our first solution, was right here, x equals 0. That's solution number 1. So we want to include the 0 inside of our curly brackets. So we have 0, and our second solution was up here. Our second solution was x equals 4. That's our second solution for the final solution set. So we need to put the 4 inside of the curly brackets. And then we have these final 2 solutions, negative 2 plus 2 square root of 3 and negative 2 minus 2 square root of 3. We need to put those ones also inside the curly brackets. So negative 2 plus 2 square root of 3, and then negative 2 minus 2 square root of 3, and all of that inside the curly brackets is our answer. (22) Find the real solutions of the equation. The square root of 6 minus 5x equals x. What is the solution set? Simplify your answer. Use a comma to separate answers as needed. Step 1. For this problem, your goal is to get the equation into the standard form of a quadratic equation, which is ax squared plus bx plus c equals 0. Then you want to use the principle of zero products to find a solution or solutions from your factorization. So that's just the goal. We want to get the problem in standard equation, use the principle of zero products, and then find our solutions. So let's rewrite the initial problem, which is square root of 6 minus 5x equals x. And then step 2 wants us to make sure that the radical is isolated to one side of the equation. The square root of 6 minus 5x is on one side of the equation, so the radical is isolated. So in this case, it wants to make sure that this radical, this whole radical term right here, is on one side of the equation, and it is. It's on the left side, so we're good there. Now for step 3, now we want to get rid of the radical on the term square root of 6 minus 5x. Remember that the index of a square root is 2, so that means that the square root of 6 minus 5x is the same as the square root of 6 minus 5x. And see, the index is right here. It's this number that's in front of the radical symbol. So we can square both sides of the equation. Squaring the square root of 6 minus 5x squared, or what we have here, will get rid of the radical. Your equation will now be 6 minus 5x equals x squared. So we want to get rid of the radical here. And to do that, let's rewrite our equation. 6 minus 5x equals x. To do that, we can just put this radical in parentheses and square it. And if we do it on the left side, then we have to do it on the right side. Squaring this radical will get rid of the radical itself. So we'll be left with 6 minus 5x equals x squared. Now for step 4, we want to add 5x and subtract 6 from both sides to get the equation into standard form. Standard form ax squared plus bx plus c equals 0. The equation is now x squared plus 5x minus 6 equals 0. So if we add 5x to both sides, we have x squared, we have 6 equals x squared minus or plus 5x, and then if we plus 5x, and then if we subtract 6 from both sides, we have 0 equals x squared plus 5x minus 6, which is the same as x squared plus 5x minus 6 equals 0. And now we have our equation in standard form, which is ax squared plus bx plus c equals 0. Now, moving on to step 5, we want to go ahead and factor the trinomial x squared plus 5x minus 6 equals 0. And since x squared has a coefficient value of 1, because x squared is the same as 1x squared, then you need to figure out what numbers when multiplied equal the third term. What two numbers when multiplied equal the third term? Negative 6, right here. And then when added, when you add the two random numbers, equal the middle term coefficient value, which is 5. For this, the answer is negative 1 and 6. So we're just trying to factor this trinomial. So x times x, and then what two numbers when multiplied equal negative 6, and when added equal 5, the middle term right here. I mean, really, you just have two options. You have minus 6 and plus 1. Well, actually, you have more than two options, because you also have 2. You could have x plus 1, x6, you could have x plus 6, and then x minus 1. You could also have different combinations of 3 and 2. You could have x minus 2, x plus 3, x plus 2, x minus 3. Alright, so let's just try these ones out. So you have 1 times negative 6, which is negative 6, which is the third term. But then when you have x times 6 is negative 6x plus x is negative 5x. This is positive 5x. So this one doesn't work. And then you have negative 1 times 6, which is negative 6, our third term. And then when you multiply it, or when you add them together, negative 1 plus 6 is 5. So this factorization, x minus 1, x plus 6, is going to be the right one. And you could even try to do the other two. Negative 2 times 3 is negative 6, but negative 2 plus 3 is negative 1, which isn't positive 5. So that doesn't work. And then you have 2 times negative 3, which is negative 6, but negative 3 plus positive 2 is negative 1. So that factorization, the last one, doesn't work as well. So now it says, step 6, use the principle of zero products to set the two factors x minus 1 and x plus 6 equal to 0 and solve for x. The result is 1 and negative 6. So if we have x plus 1 equals 0, and then x plus 6 equals 0, then we just add 1 on both sides right here. X equals 1. And then we have x plus 6, we subtract 6 from both sides, x equals negative 6. And then our solutions, our tentative solutions, are 1 and negative 6. And we can check these solutions according to step 7 by plugging in 1 and negative 6 into the original equation, square root of 6 minus 5x equals x, and once we do that, we'll see negative 6 is not a valid solution. We'll see that 1 is a valid solution, and thus your only solution is 1. So let's just do that. Let's plug in 1 and negative 6 into the original equation. So we have, let me see, we have square root of 6 minus 5x equals x. Let's substitute x for 1. So 6 minus 5 times 1 equals 1. Simplify. 6 negative 5 times 1 is minus 5 equals 1. And then 6 minus 5 is just going to be 1. Square root of 1 equals 1. The square root of 1 is 1, which equals 1. So this is true. So we know 1 is a solution. And then let's plug in our other number, which is right here, negative 6. So 6 minus 5 times negative 6 equals negative 6. So you have 6 plus 36 equals negative 6. So you have 36 equals negative 6. The square root of 36 is the same as 6 times 6 equals negative 6. 6 times 6, this simplifies to 6 equals negative 6. And this is not true. So this is false. So therefore, negative 6 isn't a solution. And step 8, put your solution 1 in set builder notation. So our solution would just be 1 inside the curly brackets, and that's your answer. 23. Solve the radical equation. The square root of 2x plus 14 equals x minus 5. So step 1. Our goal is to get the equation into standard form, ax squared plus bx plus c equals 0, and to factor and solve using the principle of zero products. So let's write our equation again. Square root of 2x plus 14. Actually, we can write it down a little bit lower. Square root of 2x plus 14 equals x minus 5. Now, step 2 wants us to make sure that the radical is isolated to one side of the equation. This preps the radical equation to be squared on both sides. The radical, the square root of 2x plus 14, is isolated on the left side of the equation. So on the right side of the equation, there's no radical. On the left side, there's this radical right here, just this one term. So this radical is isolated. Step 3, square both sides of the equation to get rid of the radical. So we want to get rid of this radical, and to do that, we can do square root of 2x plus 14 equals x minus 5, and we can square this radical, and we square the left side, we have to square the right side as well. And then that gets rid of our radical. You end up with 2x plus 14 equals x minus 5 squared, which is the same as x minus 5 times x minus 5. Now for step 4, we want to go ahead and distribute x minus 5 times x minus 5 and then add like terms. You can do that. You can go ahead and distribute each of these terms, but I actually know more of a shortcut to distribute two binomials multiplied by itself. So you have 2x plus 14 equals x times itself is just x squared, and then what you do is for your middle term is going to have the x value, so you add negative 5x plus negative 5x, which is negative 10x, and then you multiply negative 5 times itself, which is 25, because negative 5 times negative 5 is 25, and that's the factorization. I mean, you could do this right here, x minus 5 times x minus 5. If you multiplied it, you'd have x squared x times negative 5 minus 5x minus 5x. Negative 5 times negative 5 is just positive 25. Gives you x squared minus 10x minus 10x plus 25. And you can see that these two are the same. So this shortcut's a little easier. Alright, step 5. We want to get 0 on one side of the equation by subtracting 2x and then 14 from both sides. Once we do this, then the equation will now be in standard form: ax squared plus bx plus c equals 0. So we want to get want to get 0 on one side, so we can start by subtracting 2x from both sides, and that gives you 14 equals x squared. Negative 10x minus 2x is negative 12x plus 25, and then we want to subtract 14 from both sides, and then we end up with 0 equals x squared minus 12x. 14 from 25 is just plus 11, and then that's the same as x squared minus 12x plus 11 equals 0. And now we have the equation in standard form: ax squared plus bx plus c equals 0. So for step 6, we want to go ahead and factor the quadratic trinomial, and since the x squared coefficient value is 1, we need to find two numbers that when multiplied equal the third term 11, and when added equal the middle term negative 12 of this trinomial: x squared minus 12x plus 11. So we want to factor this trinomial, x squared minus 12x plus 11. Since this coefficient value of the ax squared is just a 1, we can set up the factorization just as x times x, and then we need to find two numbers that when multiplied equal the third term positive 11, and when added together equal negative 12. Right off the top of my head, I can think of negative 11 times negative 1 is going to be positive 11. Negative 1 plus negative 11 is going to be negative 12. And then once we do that, we need to take these two factorizations and set them equal to 0. I actually didn't include that there. We could put, for step 6, we could say use, this is 6, let's call this 6b. We could say use principle of zero products to find solutions of x minus 1 equals 0, or of x minus 1 and x plus 11. So we're just setting these two equal to 0 and then solving for x. X minus 1 plus 1 on both sides, x equals 1. X plus 11 equals 0. Subtract 11 from both sides, x equals negative 11. Actually, I got this wrong. This one is plus 11. It should be minus 11. So you have x minus 11, so we should add 11 to both sides, and this would give us x equals a positive 11. And then step 7, we want to go ahead and check the solutions. Check the solutions 1 and 11 by plugging them into the x value of the x values of the original equation. Square root of 2x plus 14 equals x minus 5. And if we do that, we'll find 1 is not a solution, since 4 does not equal negative 4, and we'll find 11 is a solution. So let's just do that real quick. Our original equation was 2x plus 14 equals x minus 5. Let's plug in the 1 value for x. So you have 2 times 1 plus 14 equals 1 minus 5. 2 times 1 is 2 plus 14 equals 1 minus 5 is negative 4. 2 plus 14 is 16 equals negative 4. 16 factors out to 4 times 4 equals negative 4. And then 4, this reduces to 4 equals negative 4. And that is not true. So 1 isn't a solution. Let's try 11 now. Let's plug in 11 into our original equation. So 11 plus 14 equals, substitute 11 for x, 11 minus 5. So you have 2 times 11 is 22 plus 14 equals 11 minus 5, which is 6. 22 plus 14 is 36 equals 6. 6 is the same as 6 times 6 equals 6. The root of 6 is going to be 6 equals 6, which is true, and thus 11 is a solution. So for step 8, we can just go ahead and put the solution in set builder notation. So just put 11 inside the curly brackets, and that's your answer. 23. Solve the radical equation. Check all proposed solutions. The square root of x plus 14 minus the square root of x minus 2 equals 2. Step 1. Your goal is to solve for x. You want to get x by itself. To begin solving this radical equation, isolate one of the radical terms. Add the square root of x minus 2 to both sides of the equation. This leaves the radical term square root of x plus 14 isolated on the left side of the equation. The equation is now square root of x plus 14 equals 2 plus square root of x minus 2. So let's just do this step by step. Rewrite the equation, square root of x plus 14 minus square root of x minus 2 equals 2. So we want to get x by itself. To do this, we need to get a radical isolated. We need a radical on each side. Right here we have 2 radicals on one side. We don't want that. We want just 1 radical on each side of the equation. So we can add square root of x minus 2 on both sides. And that gives us square root of x plus 14 equals 2 plus square root of x minus 2. And then step 2, to eliminate the radical on the left side of the equation, square root of x plus 14 right here, you must square both sides of the equation. However, to square the right side of the equation, you must use the formula a plus b squared equals a squared plus 2ab plus b squared. You can square the left side, the square root of x plus 14, just by putting parentheses around it. The square root of x plus 14 squared, and just squared as normal. So let's actually start with that one. On the left side, we have x plus 14. If we square it as normal, we end up with just x plus 14 equals. But right here, we need to use this formula right here. We need to use the formula a plus b squared equals a squared plus 2ab plus b squared. Now, right here it says the formula assigns 2 as the a value. So 2 is going to be our a value for this equation. So we have to plug in 2 everywhere where there's an a. And the square root of x minus 2 is going to be the b value. So square root of x minus 2 is the b value, 2 is the a value. So once you plug in the values for the variables, the formula equation is 2 squared plus 2 times 2 times the square root of x minus 2 plus the square root of x minus 2 squared. So let's plug that in. Plug in a squared, which will be a is 2, so 2 squared plus 2ab, so plus 2, a is 2, put that in parentheses, b, which is square root of x minus 2, and then plus b squared, so plus the square root of x minus 2 squared. Now moving to step 3, we want to go ahead and simplify the right side of the equation to 4 plus 4 squared x minus 2 plus x minus 2. We want to subtract 2 from 4, and the equation becomes x plus 14 equals 2 plus 4 square root of x minus 2 plus x. So we're trying to simplify the right side of this equation. We want to simplify this right side. So x plus 14 equals 2 squared is 4 plus 2 times 2 is 4 square root of x minus 2. And then when you have square root of x minus 2 squared, it just leaves us with plus x minus 2. And now we want to subtract 2 from 4. We can subtract this 2 from 4 right here. That gives us x plus 14 equals 4 minus 2 is just 2, so just 2 plus 4 square root of x minus 2 plus x. And actually it's not in here, but there should be a step 3b, which should say to subtract x and 2 from both sides. So we're trying to get rid of this x, so we could subtract x from both sides, minus x. So it leaves us with 14 equals 2 plus 4 square root of x minus 2. And then we also want to get rid of the 2, so let's subtract 2 from both sides, because we're trying to get x by itself. So 14 minus 2 is 12 equals 4 square root of x minus 2. And now for step 4, we want to go ahead and divide both sides of the equation by 4. So divide both sides of the equation by 4. 4 goes into itself once, goes into 12 3 times. It gives us 3 equals 4 square root of x minus 2. Well, actually, hold on. 4 goes into itself once, 4 goes into 4 once, so it gives us 3 equals square root of x minus 2. Now, for step 5, we want to go ahead and square both sides of the equation to get rid of the radical square root of x minus 2. And you end up with 3 squared equals square root of x minus 2 squared, which becomes 9 equals x minus 2. So we're trying to get rid of this radical right here. So to do that, we have to square both sides of the equation. So if we square the left side, it's just 3 squared. Square the right side of the equation, it's square root of x minus 2 squared. 3 squared is just 9, 3 times 3. And when you square this, it gets rid of the radical, and you're left with x minus 2. Step 6, we can solve for x by adding 2 to both sides of the equation. So add 2 to both sides of the equation, and you get 11 equals x, or x equals 11. Now that we have the solution, we can go ahead and head to step 7, which is to check that the solution is true. It wants us to plug in 11 as the x value of the original equation, square root of x plus 14 minus square root of x plus 2 equals 2. So we can just plug in the x value. I actually did it right here, but we can just do it over here as well, just so you can see. Square root of x plus 14 minus square root of x plus 2 equals 2. And then just plug in our 11 value in each instance where it has an x. So it would be 11 plus 14 minus square root of 11 square root of 11 plus 2 equals 2. Actually, right here, see an error. This should be x minus 2. Let me erase this. This should be, well, x minus 2 is right there. So we'll have x minus 2. Then we can erase it right here. It should be x minus 2, 11 minus 2. I just wrote down the equation wrong. So there we go. Square root of 11 plus 4 minus the square root of 11 minus 2 equals 2. Square root of 11 plus 4 is 25. Minus the square root of 11 minus 2. 11 minus 2 is 9 equals 2. Keep simplifying. Square root of 25 is just same as 5 times 5 minus square root of 9 is the same as 3 times 3 equals 2, which gives us 5 minus 3 equals 2. 2 equals 2, and this is true. So 11 is the solution. And for step 8, we want to go ahead and put the answer in set builder notation. So just put our solution, which is 11, put that inside curly brackets, and that's your answer. (25) Solve the equation. Check all solutions. 3x minus 16 square root of x plus 5 equals 0. Step 1. Remember that x raised to the half power is the same thing as the square root of x. X to the half power means square root of x. X to the half power is just a different way to write the same thing. And x to the half power squared equals x, since the square root of x squared also equals x. So 3x minus 16, it's the same thing as square root of x plus 5 equals 0. Step 2. Since 16x raised to the half power is 16 square root of x, a radical term, you need to isolate the radical so you can square it and get rid of the radical. To isolate 16x to the half power, add 16x to the half power from both sides of the equation. So we just want to add 16 square root of x to both sides of the equation. That way we can isolate the radical. That gives us 3x plus 5 equals 16 square root of x. Now step 3. Now that the radical 16x to the half power is isolated on the right side of the equation, square both sides of the equation. Remember to square 16x to the half, or 16 square root of x squared, so you are squaring both the 16 and the variable x. Your equation will now be 3x plus 5 in parentheses squared equals 16 squared x. So we're just trying to get rid of the radical. So we need to square. To get rid of the radical, we have 3x plus 5 equals 16 square root of x. We'll just go ahead and square this whole right side of the equation, and since we square the right side of the equation, we have to go ahead and square the left side of the equation, which gives us 3x plus 5 squared equals 16 squared. You have to square each term in the parentheses, and then square root of x squared just becomes x by itself. Step 4, distribute the terms 3x plus 5 times 3x plus 5. Well, 3x plus 5 squared is just the same as 3x plus 5 times 3x plus 5 equals 16 squared x. And 3x plus 5 times 3x plus 5, the simpler way I do it is just I multiply the first term in each parentheses. So 3x times 3x is just 9x squared. And then what I do is I multiply the second term on the first parenthesis with the middle term. So 5 times 13x is 15x. And then I just multiply, or I add 15x, or I just multiply 15x by 2, which gives us 30x. And that's our middle term, so 9x squared plus 30x. And then I multiply the last two terms with each other. So I multiply 5 times 5, which gives us plus 25, equals 16 squared x. And now for step 5, simplify 16 squared x, which becomes 256x. So we have 9x squared plus 30x plus 25 equals 16 squared. 16 times 16 is 256. Then we have x. Step 6, add like terms on the left side of the equation. 9x squared plus 15x plus 15x plus 25. We already did that. We already added 15x plus 15x to give us 30x plus 25. So we're okay. Our equation is still going to be 9x squared plus 30x plus 25 equals 256x. Now for step 7, we want to go ahead and subtract 250x from both sides of the equation to get the equation in standard form. Ax squared plus bx plus c equals 0. So we'll just go ahead and subtract 256x from both sides of the equation. So you have 9x squared. Negative 256 plus 30x is going to be negative 226x plus 25 equals 0. Now we have the equation in standard form, which is ax squared plus bx plus c equals 0. Step 8, we want to go ahead and factor 9x squared minus 226x plus 25. 9x, the ax squared term, is not a prime number, so this term could factor as 9x times x in parentheses, or 3x in parentheses times 3x in parentheses. So for our factorization of this trinomial, 9x squared minus 226x plus 25, we could set it up as 9x times times x, and then we could also set it up as 3x times 3x. So we have to think 9 times what term when added with the results of a second number times x will get you negative 226, the middle term. So we need to figure out what two numbers when multiplied equal 25, but when added equal negative 226. Well, if you multiply two numbers together, say 3 times 3, you'll get positive 9. And if you add 3 plus 3, you'll get a positive 6. But in this case, we have a positive last term, a positive third term, but a negative middle term. So really the only way to get that kind of result when factoring is you'd have to factor two negative numbers, because negative 3 times negative 3 times negative 3 is going to give us positive 9, but negative 3 plus negative 3 gives us negative 6. So I know these numbers have to be negative. So really the only thing I can think of is negative 25 and negative 1, because negative 1 times negative 25 is positive 25, our last term, and then 9 times 25 is 225, I think, times 9 is 5, 4, 225, and then plus a negative 1x, it would be negative 225, plus a negative 1 times x, which is negative 1x, would give us negative 226x, our middle term. So we know this is going to be the factorization. But even if we wanted to multiply 3x times 3x, there's really nothing that's going to help us get to this number. Even if we did like 5 minus 5 minus 5, then you still end up with, you would end up with negative 5 times negative 5 is positive 25, but 3 times negative 15, or 3x times negative 5 is negative 15x. This term right here, negative 5 times 3x is negative 15x, and if you add negative 15x plus negative 15x, you get negative 30x, and negative 30x is not negative 226x, so this one's not going to work. So this is our factorization, 9x minus 1 and x minus 25. So now for step 9, we want to, well actually let's finish reading step 8. So 9x times negative 25 gives you negative 225x, which is what we have here, and then 1 times x gives you 1x, which is what we had right here. And then when you add negative 225x and negative 1x, you get negative 256x, the middle term value, which is what we had right here. Then when you multiply negative 25 and negative 1, you get 25, the third term value, and that's what we had right here, 25, our third term value. So now moving to step 9. Step 9 wants us to use the principle of zero products to set both factorizations set both factorizations 9x minus 1 and x minus 25 equal to 0 and solve for x. So we can just set 9x minus 1 equal 9x minus 1 equal to 0 and x minus 25 equal to 0, and just solve for x. So add 1 to both sides. 9x equals 1. Divide both sides by 9. X equals 1/9. And then x minus 25, we can add 25 to both sides to get x by itself. X equals 25. And now step 10, we want to check the answers by plugging in 1/9 and 25 in as the x values in the initial equation. 3x minus 16x raised to the half power plus 5 equals 0. So we need to go ahead and plug in these values into this equation. So we have 3x minus 16x to the half power plus 5 equals 0. We can plug in 1/9 into this equation, so we'd have 3 times 1/9, and then negative 16x in the half to the half power is the same as x, so let's just do that. use that format. So square root of 1 over 9, and then plus 5 equals 0. So 3 times 1/9 is just 3/9, and then minus 16. 1/9 can be simplified more, because 1/9 is just 1/3 times 1/3 plus 5 equals 0, and then 3/9 minus 16. This right here simplifies to just 1/3. Get rid of the radical. Plus 5 equals 0. Then you have 3/9 minus 16 times 1/3 is just 16/3 plus 5 equals 0. To add these together, we need same denominator. So 9 would be the LCD. Because 3 goes into 9 and 5 is just the same as 5 over 1. So 3 times 3 gives us 9. So we have to multiply the denominator and numerator by 3. So negative 16 times 3 is negative 48. Negative 48 over 9. And then 5 times 9 on the numerator denominator will give us 45 over 9 equals 0. And then 3 minus 48 over 9 is just 45, negative 45 over 9 plus positive 45 over 9 equals 0. And that's true. That's true, so we know that 1/9 is a valid solution. So now let's plug in 25 into our original equation. So 3 times 25 minus 16 square root of x, which is square root of x, which is 25, plus 5 equals 0. 3 times 25 is 75, minus 16 square root of 25 is the same as 5 times 5, plus 5 equals 0. 75 minus 16, square root of 5 just becomes 5, plus 5 equals 0. 75 minus 16 times 5 is just negative 80, plus 5 equals 0. 75 minus 80 is negative 5 plus 5 equals 0. Negative 5 plus 5 does equal 0. 0 equals 0. So this is true. And thus 25 is a solution. And actually we don't have it, but we kind of need a step 11, which is to put solutions in set builder notation. And we can do that really easy. Just have our curly brackets, our braces. We have 1/9, and then we also have 25 as our solutions. Close it with the curly brackets, and that's the answer.